Welcome to 3D Online Tuition. It is a three-dimensional e-learning method based on audio, visual, and event.
Yippee! Yay!
Chapter 1. Introduction to Science. 1.1. Science is part of everyday life. 1.2. A science laboratory. 1.3. The steps in scientific investigation. 1.4. Physical quantities and their units. 1.5. Weight and mass. 1.6. The use of measuring tools. 1.7. The importance of standard units. 1.1. Science is part of everyday life. 1. Science is the systematic study of nature and how it affects our lives and the environment. 2. Studying science is helping us to understand the natural phenomena and things around us. It enables us to think logically and systematically. What is the natural phenomena? Natural phenomena are events occurring in nature such as the growth of a baby into an adult, melting of ice to water, lightning during a rainstorm, the coconut falls to the ground. 3. Understanding the natural phenomena helps us use the environment to improve our lives and solve problems. 4. Information obtained from science investigations is called science. 5. Science helps us to create variety of tools and methods that can help our daily lives. 6. The application of science knowledge to human use is called technology. The importance of science in everyday life. 1. Science helps us understand ourselves, helping us to better our health. 2. Science helps us understand our environment, helping us to take good care of our environment. 3. Science helps us to live better, helping us to create tools and methods that will make our life better. The contribution of science in our everyday life. Domestic. Make our household works easy. Examples: electric fans, refrigerator, TV, electric cooker. Transportation. Make our movement easy. Examples: car, train, airplane. Agricultural. Make the works of our farmer easy. Improve yield. Examples: tractor, harvester machine, fertilizers, pesticides. Communication. Make our communication better. Examples: telephone, mobile phone, TV, radio, internet. Medical. Improve our overall health. Examples: X-ray, MRI, antibiotic, chemotherapy, scientific areas of study and related careers. Biology. The study of living organisms and life process. Examples: botanist, zoologist, entomologist. Chemistry. The study of composition and chemical properties of matter. Examples: chemist, biochemist, pharmacist. Physics. The study of matter, energy and natural forces. Examples: physicist, engineer, mechanic. Medicine. The study of prevention and treatment of diseases. Examples: doctor, pharmacist. Astronomy. The study of sun, planets, stars and other universe bodies. Examples: astronomer, astronaut. Geology. The study of rocks, minerals and the structures of the earth. Examples: geologist, geophysicist. Computer science. The study of computer and its applications. Examples: computer architect, programmer. 1.2. A science laboratory. 1. Science laboratory is a place where scientists conduct research. 2. In school, science laboratory is a place where students do their scientific investigation and experiment during the science subject. 3. Student must always comply with the general rules and safety precautions when entering and using the science laboratory. General rules and safety precautions in a science laboratory. 1. Student is not allowed to enter into a laboratory without the permission from the teacher. 2. Student is not allowed to eat or drink inside a laboratory. 3. Student is not allowed to run or play inside a laboratory. 4. Apparatus and chemicals are not allowed to be taken out from the laboratory. 5. Student is not allowed to handle any chemical with hand. Please use the spatula. 6. Please read and understand the label on the reagent bottle before using it. 7. Do not waste chemical. Only use the required amount. 8. Do not return back all the residual or excess chemical to its original reagent bottle. 9. Do not taste or test any chemical without the permission from the teacher. 10. Do not throw solid waste into the sink. Throw them into the bins provided. 11. Report any broken or faulty apparatus and accident to the teacher immediately. 12. Clean and return back all the apparatus to its original places after use. 13. Tables and benches must be clean and tidy. All taps and switches turn off before leaving the laboratory. 14. Wash thoroughly your hands before leaving the laboratory. Common laboratory apparatus. Crucible. Evaporating dish. Displacement can. Filter funnel. Bell jar. Gas jar. Test tube. Boiling tube. Beaker. Conical flask. Round-bottomed flask, and flat-bottomed flask. Measuring cylinder. Burette. Pipette. Retort stand, and retort clamp. Tripod stand. Test tube rack. Spatula. Test tube holder. Bunsen burner. Stopwatch. Thermometer. Meter rule. Beam balance. Using a Bunsen burner. Usage. To heat up substances in a science laboratory. Gas tube. Barrel. Collar. Air hole. Base. Steps in using a Bunsen burner. Step 1. Close the air hole of the Bunsen burner by adjusting the collar. Step 2. Bring a lit match or lighter near to the mouth of the barrel. Step 3. Turn on the gas supply slowly until a yellow or luminous flame is obtained. Step 4. Open the air hole slowly until a non-luminous blue flame appears. The usage of Bunsen burner. Safety measures when using Bunsen burner. 1. Make sure the collar is always closed when turning on the Bunsen burner at the beginning. 2. Only use lit match or lighter as the source of fire. 3. Ignite the lit match or lighter first before opening the gas supply. 4. After the Bunsen burner is ignited with a yellow flame for the first time, open the air hole slowly until the flame turns to blue. 5. Please heat the test tube at 45-degree angle. Always shake slowly and avoid test tube from overheating. 6. Do not directly heat up flammable ingredients such as alcohol. Heat it in steamed water in a beaker. 7. When finished using Bunsen burners, close the air hole first until the yellow flame appears. Later close the gas supply. Hazard symbols in a science laboratory. Symbol. Explosive. Explodes easily when mixed with other substances or heated up. Example. natrium and kalium. Chemicals that release large amounts of heat and burn or explode when exposed to water. Concentrated acids and alkalis. Chemicals that can burn skin and contaminate other chemicals. Mixture of hydrogen and air. When the hydrogen gas is mixed with air, it will explode strongly when it is lit by fire. Proper handling method. Keep it in paraffin. Avoid contact it with water. Keep away from touching it. Keep away from other substances. Keep away from fire and heat sources. Symbol. Flammable. Catches fire and burns easily. Example. Organic solvents such as ethanol, petrol and kerosene. Proper handling method. Keep away from fire and heat sources. Symbol. Toxic or poisonous. Causes death or harm to the body when swallowed, inhaled or absorbed through the skin. Example. Mercury, lead, chloroform, bromine, benzene, sodium cyanide and hydrogen sulfate. Proper handling method. Do not taste or touch it. Follow instructions given when using it. Symbol.
Paham
Corrosive.
Takis.
Causes damage to the skin or eyes upon contact. Example. Bromine, hydrogen peroxide, acids and concentrated alkalis. Proper handling method. Avoids direct contact with skin or eyes. Wash immediately with running water if exposed to skin or clothing. Symbol. Irritant or harmful. May cause irritation or rash when exposed to the skin, eyes or respiratory system. Example. Ammonia, chlorine, chloroform, alcohol and bromine vapor. Proper handling method. Avoid inhalation. Use in a fume chamber according to the instruction given. Symbol. Radioactive. Can release harmful radiation to the human body. Example. Uranium, radium, plutonium and thorium. Proper handling method. Keep it inside a lead container. 1.3. The steps in scientific investigation. 1. Scientific investigation is a series of measures that is systematically made to investigate a problem or event. 2. Each step involves the use of one or more science process skills that require critical and creative thinking such as observing, measuring, and classifying. Identifying the problem. Identify the problem by using our four senses: sight, smell, taste and touch. Written the problem in the form of a question. Forming a hypothesis. Hypothesis is a suggested explanation for the problem that can be tested experimentally. A hypothesis is made through reasoning, observation and discussion. Planning an experiment. Identify the variables that may influence the results of the experiment. Determine the procedure of the experiment. Determine the materials and equipment used in the experiment. Methods for collecting and analyzing data obtained in the experiments. Controlling the variables. 3 variables that can influence the results of the experiment. A. Manipulated variable. B. Responding variable. C. Constant variable. Collecting data. Data is collected through proper observation and measurement. Data or decision should be recorded honestly. Analyzing data. Data is analyzed systematically, objectively and logically. Identifying the relationship between the manipulated variables and the responding variables. Interpreting data. The data is assessed through observation and measurement. Data may be represented in tables, diagrams, charts or graphs. Making conclusion. The conclusion must be based on rational and objective. If the conclusion obtained supports the hypothesis, then the hypothesis will be accepted as a law. If the conclusion does not support the hypothesis, then the hypothesis will be rejected. Writing a report. Report contains all the steps and conclusion of the investigation. Report is included with tables, diagrams, charts and graphs. 1.4. Physical quantities and their units. 1. Physical quantity is quantity that can be measured. 2. In the past, the method of quantifying physics was largely inaccurate and inconsistent. The measurement unit used also varies from country to country. 3. Since 1960, scientists worldwide have agreed to use a set of standard units known as SI units, which means International System of Units. 4. There are 5 basic quantities of physics that are commonly used. Physical quantity. Length. SI unit. Meter. Symbol. M. Measuring tool. Meter rule. Physical quantity. Time. SI unit. Second. Symbol. S. Measuring tool. Stopwatch. Physical quantity. Mass. SI unit. Kilogram. Symbol. kg. Measuring tool. Lever or beam balance. Physical quantity. Temperature. SI unit. Kelvin. Symbol. K. Measuring tool. Thermometer. Physical quantity. Electric current. SI unit. Ampere. Symbol. A. Measuring tool. Ammeter. Prefixes used in measurement. 1. Prefixes are used in expressing physical quantities that are either too large or too small. 2. Prefixes is added in front of the SI unit to change the value of the unit. 3. Milli, centi, and kilo are 3 prefixes commonly used. Other prefixes are shown in the table on the right side. 4. In the standard form, quantities written as A. Multiply 10, power of n. Where A is the same value, or bigger than 1, but smaller than 10. And n is an integer. 1.5. Weight and mass. 1. Weight and mass are 2 different quantities. Weight. Definition. The quantities of Earth's gravity applied to the object. SI unit. Newton. Features. Changed from one place to another. Measuring tool. Spring balance. Compression balance. Mass. Definition. The quantity of matter contained in the object. SI unit. Kilogram. Features. Permanent and unchanged from one place to another. Measuring tool. Lever balance. Beam balance. SI unit commonly used for weight and mass. 1 kilogram equals 10 Newton. 1 ton equals 1000 kilogram. 1 gram equals 1 over 1000 kilogram. 1 milligram equals 1 over 1000 gram. 1.6. The use of measuring tools. Measurement of lengths. 1. Length is the distance between 2 points. 2. The length of an object can be measured using a meter rule or measuring tape. 3. SI units for length or distance are kilometer, meter, centimeter and millimeter. 1 kilometer equals 1000 meter. 1 meter equals 100 centimeter. 1 centimeter equals 10 millimeter. 4. Measuring the length of an object. The correct reading is that when our eyes are right above the mark on the ruler. In the diagram on the left, the correct reading is when our eyes is at B position, which is 10.1 centimeter. 5. Measuring the length of a straight line. A. Usually several readings of the length are taken. B. The average of all the readings taken is assumed to be the actual length of the line. 6. Measuring the length of a curved line. A. Use a thread and a meter rule. B. Measure the curved line with the thread first, then use the meter rule to measure the thread. Other method is using a opasometer. 7. Measuring the diameter of an object. A. Use a pair of calipers and a ruler. B. The external caliper used to measure external diameter of an object. C. The internal caliper used to measure internal diameter of an object. D. The thickness of the beaker's wall is the difference between the outer and inner diameter, and divided by 2. 8. Measuring the diameter of a spherical object. A. Place the spherical object in between two rectangular wooden blocks. B. The diameter of the spherical object can be measured as the distance between two blocks of wood using a ruler. Measurement of areas. A. The area of an object is the size of the surface of the object. B. The SI unit for area is square meter. Other units for smaller areas are square centimeter, and square millimeter, and for large area is square kilometer. In this diagram, we can calculate the area of a leaf by using a graph paper. Every small square has an area of 1 square centimeter. Every part of the leaf that covered more than 50% of the small square shall be considered area of 1 square centimeter. From the graph paper, the number of completed square is 22. Because of each small square is 1 square centimeter. Then, the total area of the leaf is 22 multiply 1 equal to 22 square centimeter. Measurement of volumes. A. The volume of an object is the space occupied by the object. B. The SI unit for volume is cubic meter. Other units for smaller volumes are cubic centimeter, and cubic millimeter, and for large area is cubic kilometer. C. However, the most common unit for measuring volume is liter, and milliliter. 1 cubic centimeter, equal 1 milliliter. 1 liter equal 1000 milliliter. Equal 1000 cubic centimeter. 1. Measuring the volume of liquids. A. The volume of liquids can be measured by using a measuring cylinder, a pipette, or a burette. B. The liquid's level is curved in the measuring cylinder. This curved portion of the liquid's called meniscus. C. When measuring liquid volume in a measuring cylinder, the correct reading is where the position of the eyes are at the same level with the bottom of the meniscus. D. Meniscus of all liquids are curved to the bottom, while meniscus of mercury is curved upwards. E. When measuring the liquid with a measuring cylinder, make sure that the measuring cylinder is put on a flat surface while taking the reading. Do not hold the measuring cylinder in the hand while taking the reading. F. To measure the liquids with more accuracy, we used pipette and burette. G. Pipette is used to accurately measure specific volumes of liquid, such as 10 milliliters, 25 milliliters, or 50 milliliters. H. When using a pipette. Firstly, suck the liquid from the beaker into the pipette, by using a pipette pump. Let the liquid rises above the mark on the pipette. Then, release slowly the excess liquid back into the beaker until the bottom of the meniscus of the liquid reaches the mark on the pipette. I. Burette is used to measure any volume of liquid, up to the accuracy of 0.1 milliliters. J. When measuring the liquid with a burette, first, clamp the burette vertically to a retort stand, with the tap of the burette is closed. Then pour the liquid that need to be measured into the burette, using a filter funnel. Early reading on the burette is recorded. Put a piece of white paper on the back of the burette, so that the meniscus of the liquid can be read more clearly. The tap is open to release the liquid into an empty beaker. Close the tap and the final reading is recorded. The difference between the initial reading and the final reading is the volume of the liquid in the beaker. 2. Measuring the volume of a solid object. A. The volumes of irregular, or irregular solid objects, can be measured by using the water displacement method. B. To measure the volume of an irregular solid object like a stone. First, fill the measuring cylinder with water. The initial reading of the volume of the water in the measuring cylinder is recorded. After that, place the stone into the measuring cylinder slowly. The water in the measuring cylinder will rise, and the final reading is recorded. The difference between the initial reading and the final reading is the volume of the stone. C. Water displacement method can also be done with Eureka can. First, fill the Eureka can with water until the water level exceeds the level of the spout. Let the excess water flows out from the spout. After the flows out water stops, place a measuring cylinder below the spout of the Eureka can. Now, place the stone that need to be measured into the can slowly. The water will rise, and flow out of the can into the measuring cylinder through its spout. After the water flow stops, the reading in the measuring cylinder is equivalent to the volume of the stone. Measurement of temperature. 1. Measuring temperature. A. Temperature is the degree of how hot or cold of an object. B. The SI unit for temperature is Kelvin, K, but other units such as degree Celsius and degree Fahrenheit are more frequently used. C. Temperature is measured using a thermometer. A mercury thermometer is commonly used. D. The clinical thermometer is used to measure the temperature of the human body. The measuring range of the clinical thermometer is between 35 degrees Celsius and 42 degrees Celsius. E. The clinical thermometer consists of a bulb containing mercury, and is connected with a capillary tube. F. The clinical thermometer has a constriction, close to the bulb, to prevent mercury from flowing back when the thermometer is removed from the place where the temperature is being measured. G. To measure the temperature of the human body, the clinical thermometer is placed under the tongue, or under the armpit. The normal human body temperature is 37 degrees Celsius. H. Lab thermometer is used for measuring the temperature of liquids. The measuring range of the lab thermometer is between -10 degrees Celsius and 110 degrees Celsius. I. To measure the temperature of a liquid, the lab thermometer is holds at the position where the thermometer is at the center of the liquid without touching the beaker wall. When the thread of the mercury in the thermometer stops going up or down, the temperature reading is recorded. Accuracy in measurement. 1. The accuracy of a measurement depends on how close the measured value is to the real value. 2. The accuracy of a measurement can be increased by 1. Use a more suitable measuring tools, such as burette, instead of measuring cylinder, due to the divisions on the burette scale is smaller. 2. Use a correct techniques, such as a correct eyes positioning, while taking a reading. 3. Using an average reading from several readings, instead of a single reading, will provide a more accurate measurement. 1.7. The importance of standard units. 1. In the past, measurements were made using the part of the human body, such as the palm, hand and feet. But it creates a lot of trouble, because the size of the palm, hand, or feet, are different from one individual to another. 2. Before SI units were introduced in 1960, the standard units used for measuring length, weight, and time were feet, pounds, and seconds. This standard system unit is known as foot-pound-second, FPS. 3. Then, the meter-kilogram-second, MKS, system, was introduced in Europe. 4. In 1960, the International System Unit, SI, was adopted as the world standard measurement unit. With this SI units, scientists around the world can communicate and share information with greater accuracy.
Happy learning